In this episode, we're going to look at the routing system. Now firstly, I know that Americans pronounce that word as routing, but I'm British and we have an international audience, so throughout this episode I'll be pronouncing it as routing. Okay then, what is routing all about? Well, in ASP.NET before routing, it was normal for URLs to match physical ASPX files on disk. But with ASP.NET MVC, that wouldn't even make sense, because controllers are .NET types compiled into an assembly. There aren't any files on disk that URLs could match. Plus, people often want to have tight controls over the URLs that their application uses. Maybe you'd want to do this for search engine optimization reasons, maybe for usability reasons, or maybe just so that you're not coupling your URL structure to your Visual Studio project structure, which means in future you could safely restructure your project without breaking all your incoming links. Well, the routing system is a way to deal with all this. It's a way to configure what kinds of URLs you'll accept and how they should be handled. Routing is no longer specific to ASP.NET MVC, it's now supported by web forms in version 4, but when you do use it with ASP.NET MVC, you're using it as a way to configure how URLs map onto controllers and actions. Routing has two main jobs. Firstly, it matches inbound URLs each time a request comes in, and secondly, it generates outbound URLs each time you try to place a link or do a redirection. Let's have a quick look at how it does its first job, inbound routing. When a request comes into your application, an ASP.NET module called URL Routing Module catches it and inspects the URL. It only considers the path part of the URL, which means not the protocol, not the hostname, and not the query string, just the part that looks like it could be a path on disk. Now you'll have configured the routing system with one or more route entries, each of which describes a URL pattern to match, plus other configuration settings such as default values for placeholder parameters. The routing system starts at the top of the list and iterates down. It finds the first routing entry that matches the incoming request, and from that it constructs an object called routeData that describes the parameters extracted from the URL. The route entry also specifies a handler to be responsible for processing the request. In ASP.NET MVC applications, this is nearly always an object of type MVC route handler. Now MVC route handler knows how to hand off the request to the real ASP.NET MVC framework to be processed. It passes along the route data structure so the framework can see what controller and action to invoke. And this process happens every time a request hits your application. Your job is just to configure the route entries so the right URLs map to the right controllers and actions. Routing's other major job is generating URLs that you can use when you're placing links or redirections. It's essentially the inverse of inbound routing. So if you use the HTML.action link helper to place a link, firstly it internally expresses your parameters as a route data structure. It can then pass this structure onto the routing system and ask for the corresponding URL. The routing system again starts at the top of its configuration list and iterates down until it finds the first configuration entry that could generate those route data values. And once it's found one, it uses that pattern to construct the URL, and if you provide in any extra unused parameters, it appends these unused parameters to the query string, so they could later be mapped back to action method parameters. And finally, ASP.NET MVC uses that URL when rendering the link tag. So why bother with all this? Well, if you didn't use outbound routing and instead constructed URLs manually, then you'd have no guarantee that when the user followed the link or the redirection, they'd end up in the right place. Using outbound URL generation means that whenever you update your routing configuration, all your links to other controllers and actions are updated to match automatically. Let's now have a look at this in action. Now you probably remember this job ads application that we've been building over the last few episodes, but let's see what happens if we try to go to the root URL. So I'll just delete all of this stuff from the URL, and you can see that we get an error. To understand why we're getting an error, let's have a look at our routing configuration. And this is the default configuration that you get with any new ASP.NET MVC2 application. And what it says is that if nobody has specified otherwise, then requests should be handled by a controller called home and an action called index. But in this application we don't have any controller called home. So let's start by changing the default controller name from home to jobs, since we do have a controller called jobs controller. Now if I recompile, switch back to my application and reload the root URL, now by default we get the index action on jobs controller, which is much more useful. Okay, so next I could try searching for something, and we might notice that these links, or you might think that they're links, but they're not, because when I try to click them, nothing happens. So let's now turn them into links that a visitor could follow. On my view, I'll replace the title with an HTML.action link. and the text to display will be the job title. And now I can specify other parameters that will be passed to the routing system to generate an outbound URL. Firstly, I'll specify the action name of details. There is no such action yet, but that doesn't matter. And now some more parameters. I'll pass an ID parameter, which shall be the job ads ID. Now if I reload this page, we'll find that the links are clickable. And the URL that's been generated, job/details/16, matches up with the configuration that's been given in our routing configuration. Name of a controller / name of an action / ID if there is one, although that's optional. But as I mentioned, there isn't any action method called details, so that's just returning a 404 right now. To proceed with this, I'm going to have to create that action method. That won't take very long. On jobs controller, I'll add a new action method that returns a view. And it can receive the ID value from the incoming request. I use a link query to fetch the job ad by that ID, and then I'll simply return a view to display that job ad. Of course, I need to actually add a view for that, so I shall just create one now. I'll say that it's strongly typed and specify that we are rendering a job ad. And I'll just tidy this up slightly. And I'll just add a minimal amount of markup so that we can see it's working. Okay, so recompiling, switching back and reloading. We've now got working links that bring up details about the jobs. Okay, but this episode is all about routing, and so perhaps what might be useful is to think about how we can improve our URL structure slightly. One thing that's a bit odd at the moment is that all of our job details have got the word details in the URL, which is kind of redundant really. You might think it would be specific enough just to request job/16 to get the details about job 16, but of course that will give us 404 not found right now, because under the default routing configuration that tries to match a controller called jobs and an action method called 16, but of course we don't have any action methods called 16, so that's just going to return a 404. We can make this work by editing the routing configuration. I'll create a new entry, and you can give names to routes, but also you don't have to, and I usually don't want to, so I'm just going to pass null for the name right now, and we'll talk a bit more about named routes later. Next I specify URL pattern to match, and I'm going to match URLs of the form jobs/ID, and if I wanted I could just stop there because that's a valid routing entry. However, if an incoming request matches this entry, the MVC framework won't know what controller and action to invoke because we haven't specified them. Since they're not being specified by the URL, I need to specify them as defaults. The third parameter lets me pass some defaults, so I'll say that this route matches a controller called jobs and an action called details, and now that hopefully should be enough. And because this new entry has gone at the top of the list above the previous one, it has priority over it. So when a URL comes in, it will first be matched against this pattern, and only if it doesn't match that pattern will it be considered against this one. So now back in the browser, this URL that produced a 404 not found before, I'll try reloading it, and now we can see it matches the updated routing configuration. Brilliant. Okay, so let's try doing another job search right now. I'll search for C# this time, and then we get a strange error. So somehow our new routing entry has broken the site. Actually, it's quite easy to understand why, because what's happened is that it's matched jobs/something, and it thinks that the word search here is an ID. But jobs/search is a valid match for this pattern. But that's not what we want. We only want it to match ID values that are numerical, so we can specify a constraint for that. The fourth parameter lets me specify constraints, so I'll say that the ID value has to match the following regular expression, and this says that it's a non-empty sequence of digits and nothing else. If you give a string here, it'll be treated as a regular expression. Otherwise you can pass an object that implements iRouteConstraint, and that allows you to write your own custom constraint logic. Anyway, with this constraint in place, I'll try reloading the application again, and now everything seems to be working again. So I can run searches, and when I click on an entry, the details appear and it's using the nice URL pattern that we just defined a minute ago. And now just to prove that the ordering of the route entries is critical, let's imagine I cut this out and paste this back in above the previous one. So now that top entry takes priority. If I recompile and try to reload this URL, I'll get a 404 not found, and that's because jobs/6 now matches a controller called jobs, and an action called 6. Of course there's no such action, so that will just fail. This illustrates the golden rule of routing, which is that you must always put the most specific entries first. In this case, this is a more specific entry, so it needs to go first. So any URL of the form jobs/a number will be matched by this one, and all other URLs will be considered as candidates to match against this one. Okay, you've now got a feel for the sort of simple things that you can do with routing, and the fact that you can configure it as a list of entries in global.asax, but let's take a step back and consider more formally what the configuration options are and how the routing system decides whether or not to match a given entry. When you call routes.maproute, there are 4 main parameters you can pass. The first parameter is the name for the route entry, or you can pass null to have an anonymous route entry. Normally, I prefer my route entries to be anonymous for reasons I'll explain later. The second parameter is the URL pattern. This can include parameters that are enclosed in curly braces. By default, all of these parameters are treated as required, so this entry would only match an incoming URL if it contained exactly 3 URL segments. And by segment I mean a string separated by forward slashes. And this would only match if the first URL segment was the word jobs. Similarly, for outbound URL generation, this entry would only match if you supplied values called city and page index. Third, you can supply defaults. These serve 2 purposes. Firstly, they make the corresponding parameter optional. So now, if an incoming URL had only 2 URL segments, for example jobs/London, it would match this entry, and the page index routing parameter would be set to 1. Similarly, for outbound URL generation, it now means you wouldn't have to set a value for page index, and if you didn't, then it would generate a URL with only 2 segments, because the third segment is optional. Note that it wouldn't be meaningful to say that city was optional but page index was required. There's no way you can omit a parameter from the middle on its own. To be a valid URL, you can only omit a continuous sequence of parameters from the right-hand end. The second purpose for defaults is to give values for extra parameters that are not included in the URL. For example, since this URL doesn't have a parameter called controller or action, we need to specify those parameters using the defaults list. The fourth parameter is constraints, and this specifies restrictions about what incoming and outgoing values are allowed for specific parameters. Normally, these are defined as regular expressions. Now, as I mentioned, for both incoming and outgoing routing, the matching algorithm is to start at the top of the list and work down the list to find the first match. It doesn't try to find the most specific match or anything like that. It stops when it hits the first acceptable match. Now, a given route entry is considered to be an acceptable match under the following conditions. Firstly, every parameter has to have a value, either a value from the incoming URL or in your outgoing parameters, or a default value, but it has to have one of those, otherwise the route entry won't match. Secondly, all constraints have to be satisfied, and this applies both to values extracted from incoming URLs or for outgoing URL generation to the parameters you've provided. If some constraint is violated, then the route entry won't match and the system will just move on to the next one. The third condition applies only to outbound URL generation. In this example, we've got 2 default-only parameters, controller and action, which are specified as defaults but aren't in the URL. For outbound URL generation, if you supply values for those parameters, then your specified values have to match the defaults. Because, for example, if you said you wanted to link to some controller other than jobs, then this route entry could never do that, so it shouldn't match. The final point also only applies to outbound URL generation, and that is that if you supplied extra parameters that aren't in the URL or the defaults, then your extra parameters will be appended to the query string. The inbound routing system will ignore query string parameters, but the MVC framework will still map them onto action method parameters. Now you know the basics of how this stuff works, let's move on to consider a few more features of the routing system. Firstly, we'll think about how this relates to physical files on disk. Now you know that routing system is supposed to give you independence of the way that your files are physically structured, but sometimes you do want to actually match the files. We'll talk about that. Next, I'll explain what purpose named route entries serve, and then we'll look at how you could create custom route handlers, which bypass the whole of the ASP.NET MVC framework and would let you create your own web development platform directly on top of the routing system. Let's think about how the routing system relates to physical files on disk. To illustrate this, look at this URL, content/styles.css. If I request this URL, it brings back the style sheet at that location. Well, that's nothing very special, you might think. But just hang on a minute. Why doesn't this get mapped to a controller called content and an action method called styles.css? It does seem like it should match this routing entry, content/styles.css and ID being optional. And since there is no controller called content controller, you might expect it to give an error message. But it didn't, it returned the CSS file. And the reason this happened is nothing to do with the file name extension. It's because the routing system checks whether or not the incoming URL does happen to match an actual physical file on disk, and if it does, the routing system ignores the request, which leaves the web server just to serve the physical file. And to prove that, I can turn off this behavior. If I change the configuration slightly to say routes.rootExistingFiles equals true, and that means it will no longer ignore existing files on disk but will root them, then when I compile and reload this URL, it will get mapped to a controller called content, and since that doesn't exist, there's an error message. Okay, now if we did want to leave root existing files turned on, but yet we did want to successfully serve content/styles.css, what could we do? Well, we could use another feature of the routing system, which is to mark out certain portions of the URL space as being ignored. I can do that by saying routes.ignoreRoot, and then I give a pattern for URLs that should be ignored. So I might want to ignore everything of the form content/path. And now I'll recompile, and since this URL matches that pattern, when I reload, it will start serving the CSS file again. Okay, that's good, but what if I had CSS files in some subdirectory? Like this. Now that wouldn't match this pattern anymore, because this pattern only has 2 segments in it. This could be a bit awkward, because we might want to match against URLs with an arbitrary number of segments. Well, actually that's not awkward, it's quite easy, because you can use another feature of the routing system called catch-all parameters. If you put an asterisk as the start of a parameter name, then it will be treated as a catch-all parameter, and that means it doesn't just match one URL segment anymore, it now matches an arbitrary number. So this would catch files in all subdirectories. And that's exactly how this default entry works, which tells the routing system to ignore all requests with a .axt extension, no matter what else appears in the URL. And in case you're interested, that's needed to make the ASP.NET tracing system work, which uses URLs of the form trace.axt/some other stuff. Also, you're not limited to using catch-all parameters when you're ignoring segments of the URL space. I could also here set ID to be a catch-all parameter, which means we can now take URLs of the form jobs/a/b/c and so on, and the entire string after jobs would be matched to the parameter ID. Of course, when you're using catch-all parameters, these have to be the final things in the URL because they match everything from where they appear up until the end of the URL. Okay, so that's how the routing system matches existing files on disk, how you can disable that behavior, how you can ignore sections of the URL space, and how you can define parameters that match multiple URL segments. But we don't really want any of this stuff I've just added, so I'm just going to revert all of this. Next, let's talk about named root entries. So far we've got one root entry with a name, default, and another root entry with no name at all. Well, why would you want names? It's to do with outbound URL generation. It gives you another way of specifying which root entry you want to generate a URL based on. Back in our view, currently we're generating a URL here with this action link without saying which root entry we want to match, so the routing system uses its algorithm of finding the first matching root entry. If you wanted to specify exactly which root entry should match, you could use a different method overload, html.rootLink. And now the second parameter here is some root name. And because this overload doesn't take a parameter called action, I'm going to have to add that to this list of custom parameters. Okay, so now I've done that, I'll recompile and try re-rendering this view. And of course we get an error because there is no root called some root name. Let's change that to a real root name. The only one we've got is default. So I'll re-render again. And we now look at the URLs that have been generated. We can see that they're of the form controller/actionname/ID. And that's because it's matched against this root entry, controller action ID. Now the slight drawback to using named root entries is that it only works for outbound URL generation. The inbound routing system will ignore the names entirely. So just because you've generated a URL using a particular root entry, when that URL comes back into your application later, it won't necessarily match against the same root entry. There might be some higher prioritized one that matches it as well. This kind of inconsistency can be very confusing. Plus, since named root entries involve coupling your views to your routing entry names, it means that if you change your routing configuration, you might have to go and find everywhere that it's referenced in all the different views and update those. I personally prefer to avoid both of these problems by not giving names to my route entries, so I know that inbound and outbound routing has got to be consistent, and also it means that I don't have to update my views if I later update my routing configuration. The next thing to talk about is custom route handlers. Now when you call routes.maproute, by default it sets up a route handler called MVC route handler, which knows how to use your controller factory to invoke a controller in action inside ASP.NET MVC. But of course you can bypass all of that by creating your own custom route handler. Here's a very simple example. I'll start by creating a class that implements iRouteHandler. When I implement that interface, you'll see it just has this one method. And that method requires me to return an iHTTP handler that can actually handle the request. So I'll just create one of those right now. I'll implement that interface. And I'll say that this object is not reusable. So anyone that uses it should construct a new instance each time. And now I can do something to handle the request. Actually, I think I'll demonstrate how we can take parameters from the routing system. So I'll create a new property on this handler. And I'll display that. Of course, I should HTML encode it to avoid any cross-site scripting vulnerabilities. And now I can return one of those from my route handler, populating its greeting property from a route data value. Okay, now I've created this custom route handler, I can actually use it in my routing configuration. I can't call routes.maproute because that doesn't allow me to specify the route handler that I want to use. So I should use a different way of adding a route entry, routes.add, new route. I'll match the URL pattern hi/greeting. And I'll say that this should use my route handler. Okay, calling routes.add and then constructing your own route instance is exactly what the routes.maproute helper does behind the scenes. So doing it this way just gives us the opportunity to specify our own route handler. Now with all this in place, I should be able to visit the URL hi/something. And indeed it does run the custom route handler and passes our parameter through to it. And this has bypassed the controller factory and everything inside ASP.NET MVC. I don't think that there's very many common scenarios when an ASP.NET MVC developer would want to do this, because an action method is itself an extremely general purpose way of handling HTTP requests. The ability to provide a custom route handler is mainly useful if you're building your own web development platform, and it's how both ASP.NET MVC and ASP.NET Web Forms since version 4 integrate with the routing system. Okay, let's step it up a gear and think about the real problem of search engine optimization. Well, everybody wants their pages to be at the top of the search engine results list, and we generally believe that search engines give priority to pages that have relevant keywords in the actual URL. Of course, the routing system can help us to achieve this. So right now, if I visit a job details page, I might have a URL like job/107. That doesn't really have very many relevant keywords. I might prefer that to be something like job/USA/Detroit/Ruby consultant. I'm going to start by creating a new utility class called routingutils. And inside there, I'll create a method called detailsRouteValues as an extension method on job ad, and have it return all the route values that I think are relevant when someone's navigating to a job ad details page. So we know that to view a job ad's details, you need to go to a controller called jobs, and to an action called details, and you need to specify the ID, which is the job ad ID. Now the other keywords that we think of as relevant and want to include as well might be country and city, and of course the job ad title itself. Right, so now I've got a way of constructing all these routing parameters, I'm going to actually use it to generate my URLs. Firstly, since this is an extension method, I have to import its namespace in order to be able to access it in any given view. So I'll copy its namespace, and in my webconfig file, under the list of namespaces that are made available to views, I will add a new one, and that's this namespace. Now I can access that extension method in my view. I'll go to the search results page, and where we generate the URL, instead of using action link, I'll use another helper, route link, that we used a moment ago, and this allows me to specify an arbitrary collection of routing parameters, and we'll generate a URL based on that. So, as well as the link title, I'll specify the route values, which are given by the extension method I just created. Okay, let's see what kind of URLs it generates now. I'll go back and click on the link again, and this time if we look at the URL, we'll see that all the extra parameters that we've asked for have been appended as query string parameters: country, city, title. And of course the link still works because the only thing that our action method actually cares about is getting the ID. It will ignore all the other parameters. Now we can update the routing configuration so that those parameters actually appear in the main part of the URL instead of in the query string. I'll go back to the routing configuration and set up the route to be of this form: job/country/city/title/ID. Now I recompile, go back and reload this page. Click the link yet again, and if we look at the link now, we've got pretty much the exact URL that we wanted. There are only two slightly strange things about it. One of them is that we've got the ID in it still, and you might argue that we shouldn't really need that because it should be specific enough just to say USA/Denver/Ruby consultant. And yes, it's true that we could add some extra code to try and fetch the domain entity based on that alone. However, that would be quite awkward, and it's possible that we could get ambiguous matches. So since it's not really harmful to leave the ID in the URL, we might as well do that. The search engine probably won't care, and end users probably won't notice either unless it's really long and difficult to type in. The other thing that's slightly strange about this URL is that we've got a space in it between Ruby and consultant. People don't normally have spaces, and also it's all a mixture of upper and lower cases, and it's more normal for URLs to be generally lowercase. Of course that's just a matter of preference, but I don't really like to have spaces particularly, so I'm going to normalize my URL now. And to do that, I'll go back to routing utils again, and I will create a further method. And my logic will be that, firstly, if someone passes a null, I'm just going to replace that with an empty string. And then I'm going to get rid of any exterior white space. And next, I'm going to replace any interior white space with a dash character, because I've heard advice in the past that Google at least likes dash as word separators. And finally, I don't want any unusual characters in these simple URL segments. So I'll use a regular expression to replace any character that's not simply 0 to 9 or A to Z, or the dash character, and get rid of it. And of course that should be done case insensitively. And now when we're returning these root values, I will replace anything that could contain special characters with a simple value. I know this is potentially losing information, but we don't care because we're actually ignoring all of these special URL segments. They're only there for search engine reasons anyway. Oh, and finally, I'll have the whole thing in lowercase. Right, now I will recompile. I will go back to my application, reload this page, and click the link again. And this time, if we look at the URL, this is much more like what I expected and wanted in the first place. Okay, now there's one further problem about the way that we've achieved this, and that is that you can type any garbage you like in for one of these URL segments and the link will still work. And maybe you think it's good that things still work and it's good to have this kind of fault tolerance, but actually it's not in this case. This is what search engine optimization people called a non-canonicalization problem. And this is to say that you've got multiple different ways of reaching the same content. And so if different people are linking to that same content using different URLs, this means the search engine might index your content under multiple URLs where each one of those URLs has a low ranking. It would be better to present that content on a single URL with the weight of all the incoming links concentrated there, so that single URL gets a high ranking. To achieve this, we need to prevent people from visiting that content using the wrong URL, and preferably we'll automatically redirect them to the correct URL. This is called enforcing canonical URLs. It's quite easy to do. I'm going to add an extra method into my controller called enforce canonical URL. It will take a set of routing parameters that define what URL the user should be on right now. And so if the visitor is using the wrong URL, then we can redirect them to the correct URL. Note that normal HTTP redirections with a 302 status code are considered to be temporary redirections, and since they're temporary, the search engine won't take account of them when it's building its search index. But if we use a permanent redirection with a 301 status code, then the search engine knows that what you're saying is that the content should really be accessed from this other URL, and so it will account for that when it builds its search index. Okay, so that does a redirection if necessary. And now we can use that very easily from the details action by simply saying that we want to enforce the canonical URL based on this job ad's details root values. So I'll recompile, and now I'll try reloading this bad URL, and we can see that the user has automatically been redirected to the canonical URL, and that avoids any risk of our search engine ranking being diluted by people using incorrect URLs. Also, it means that if you wanted to link to this page from some other web application that knows the ID of the job ad that it wants to link to but doesn't know any of the other details, then you could simply place a link as follows, just using slashes for all the URL segments that you don't know the values for. And when this URL hits the application, of course the user will be redirected to the correct URL. A couple of points about this code. Firstly, if you're running on .NET 4, you can use the response.permanent redirect method instead of setting the status code manually. And secondly, I'm aware that the way I've written this would make unit testing quite difficult. However, I'm not unit testing the details action, so I don't really care about that. Okay, so that's how we can get relevant keywords into the URL without having to really mess around too much with our controllers or views. The final thing for us to cover in this episode is areas. Now, areas are not actually a feature of the core routing system, it's a feature of ASP.NET MVC 2, but it is mainly to do with URLs and routing, so it is relevant to cover during this episode. Now, the idea with areas is that they give you a way to break down your application into smaller groups of files, where each group can contain its own controllers, its own views, its own content files, and its own routing configuration. It's just a way of organising a large application. For example, in this application, we might want to add some sort of content management area where people can view articles and other people can upload and edit articles. And if we wanted to keep all that separate from the job ads listing, we could put it into a separate area. Now, the easiest way to create an area is from Solution Explorer, just to right-click your project and say Add Area. So I'll create one called CMS. Now let's ignore this file that's appeared at the moment, we'll come back to that in a minute. Firstly, I'm going to add a controller to my area, call it Articles Controller, and it might render a view, so I'll add a view, and I'll just put some placeholder text in there for now. Okay, now I should be able to reach that in my browser at the URL cms/articles/index. And indeed it works. Okay, so let's review what we've got and how it works. If we look at the folder structure that's been created, we've now got a top level folder called Areas, and inside that one for CMS, which has got its own controllers, models and views, and as you can see this kind of mirrors the folder structure of the main project. We can think about all these files as a group, and theoretically we could even reuse them between projects. But why did the URL cms/articles/index reach that action? Why didn't it look for a controller called CMS controller and an action called articles? Well, it didn't do that because it matched a different root entry, one that isn't even configured here at all. And if you look down here in the application start method, we see that we've got this method arearegistration.registerAllAreas. And what this does is it tells the framework to scan your assemblies for all types that inherit from area registration, and for each one of those to call a special method on them to register that area. And when we created the CMS area, Visual Studio created this class for us, CMS Area Registration, which does inherit from area registration, and it has a register area method which sets up its own separate routing configuration. And this now means that all URLs starting with CMS will be matched by this root entry. And of course each area can define its own custom root entries. So for example, I could map a new route, and I won't give it a name. I'll just say that the URL articles list should map to a controller called articles and an action called index. And now I've done that, I should be able to request that URL. And as you can see, that does work. And that's how each area can define its own routing configuration. Now there really isn't a lot more to say about areas, they basically just do what you'd expect them to do. But there is one slightly surprising problem that you might encounter, so I'm just going to demonstrate that and show you how to work around it. The problem is to do with having multiple controllers with the same name. Normally it's fine to do that as long as they're in different areas. That's kind of the whole point of areas. But there is an exception to that rule, and that's to do with controllers that are not inside any area at all. If one of your top level controllers happens to clash with the name of one of the controllers inside an area, you might have a problem. Let me show you. To demonstrate it, I'm going to add a new controller to the CMS area called Jobs Controller, just to make sure it clashes. I'll just make it do something really simple to demonstrate the fact that it's running. So now I should be able to reach that controller on the URL cms/jobs. And that works. But what happens now if I try to request the Jobs controller at the top level of my application? Now I have a problem. Multiple controllers were found that match the controller name Jobs. It's an ambiguous match, so it's given up. Well, yes, that is true. There are multiple controllers with the name Jobs, but why did it work last time and it doesn't work this time? The reason for that is to do with how the routes are registered. Now, when an area registers routes by calling context.maproute, internally it sets up an extra parameter that tells the routing system to give priority to controllers that are inside the namespace corresponding to this area. So when you request cms/jobs, it will match this route entry and it will go looking for a controller inside the jobads.areas.cms.controllers namespace, and it will find this one. But global routing entries don't specify anything about namespaces. So if you request jobs, it will give equal priority to all jobs controllers anywhere in your application, and if there's more than one, that will fail. The way to resolve that problem is to pass an extra parameter when calling routes.maproute to tell it to prioritize controllers in a particular namespace. So in this case, I don't want to set any constraints, but I do want to pass a namespaces parameter, and I'll say that we should be giving priority to controllers in the jobads.controllers namespace, because that's where my real jobs controller lives. And now if I recompile and reload this URL, we'll see that it works. And I'll try searching for something, and that works too, and I'll click a link, but this one fails. And the reason that fails is that it matched a different route entry. It matched this one. So I need to specify the namespaces there as well. Recompile, reload, and this time it does work. Okay, so that's how you can create an area, how you can create controllers and views inside it, how you can create custom route entries on a per area basis, and how you can avoid clashes between controllers at the top level of your application and controllers in specific areas. That's enough for this episode. I think that's pretty much all you'll need to know about routing and areas.